Next see example 2.9. What is that? Example 2.9. F z1 which is equal to f z1 is equal to 3 plus 4i, z2 which is equal to 5 minus 12i, and z3 which is equal to 6 plus 8i. Find it. Modulus z1, z2, z3 and z1 plus z2, modulus z1 plus z2, modulus z2 minus z3 and modulus z1 plus z3, modulus z1 plus z3. Find these values. Given z1 value, z2 value and z3 value. See the solution. What is given, Rakana? Given z1 value, that is 3 plus 4i, and z2 which is equal to 5 minus 12i, z3 which is equal to 6 plus 8i. Now find it modulus z1. Find it modulus z1. So modulus z1 which is equal to modulus 3 plus 4i, which is equal to modulus mean taking square root of real part square, imaginary part square. Imaginary part is here 4. 4 square. 3 squared is 9 plus 4 squared is 16, which is equal to, what's the value of 9 plus 16 ma? Yeah, 25. So modulus of z1 equal to square root of 25 values 5. So modulus of z1 is equal to 5. Next find it modulus of z2. Modulus of z2. So z2 which is equal to 5 minus 12i. So modulus of z2 equal to modulus 5 minus 12i. So taking square root of 5 square plus of, here imaginary part is minus 12. So minus 12 square, which is equal to 5 squared is 25. 12 squared is 144, which is equal to square root of 144 plus 25 values ma. Yeah, 169. Square root of 169 is, yeah, 13. So modulus of z2 equal to 13. Next z3 value which is equal to, next z3 value, modulus z2, yeah, z3 values 6 plus 8i. So modulus of z3 which is equal to modulus of 6 plus 8i, modulus of 6 plus 8i, which is equal to square root of 6 square is 36 plus imaginary part is 8 square. 6 square 36 plus 8 square 64, which is equal to square root of 100. Square root of 100 values, yeah, 10. So what is it? Modulus of z3. So modulus of z3 equal to 10. We found the value of z2, z3 and z1. Okay, z1, z2 and z3. Next find modulus of z1 plus z2. Next to find modulus of z1 plus z2. So we need value z1 plus z2, then take it modulus. So first find z1 plus z2. What is z1? z1 is 3 plus 4i. Say and write it. 3 plus 4i. z2 is plus 5 minus 12i, which is equal to 3 plus 5 is 8. 4i minus 12i is, yeah, minus 8i. Okay. Now taking modulus z1 plus z2, which is equal to modulus 8 minus 8i, which is equal to square root of 8 square plus of minus 8 square, which is equal to square root of 8 square is 64 plus minus 8 square, that also 64. Square root of 64 plus 64 is 128. Okay, there is not a perfect square, so we can write it as 64 into 2. So write it separate square root. 64 square root of 2, which is equal to square root of 64 values 8. So 8 into root 2. We can write it as modulus of z1 plus z2 equal to 8 into root 2. Next, find it modulus z2 minus z3. Modulus z2 minus z3. So find it z2 minus z3, which is equal to, what is z2? 5 minus 12i minus of z3 is 6 plus 8i, which is equal to 5 minus 12i minus 6 minus 8i, which is equal to 5 minus 6 is minus 1, minus 12i minus 8i is minus 20i, minus 20i. What is it? Z2 minus Z3 equal to minus 1 minus 20i. Taking modulus. So modulus Z2 minus Z3, which is equal to minus 1 minus 20i. So modulus minus 1 minus 20i, which is equal to square root of minus 1 square plus of minus 20 the whole square, which is equal to square root of minus 1 square is plus 1, minus 20 square is plus 400, which is equal to square root of 401. There is no perfect square term. Okay, we can split it into, no, 1 into 401 is only the table exists. Am I right? So it is a prime number. So modulus of z2 minus z3 is square root of 401. Next, find it. Modulus z1 plus z3. What is it? Modulus z1 plus z3. z1 plus z3. First we find, what is z1? 3 plus 4i plus z3 is 6 plus 8i, which is equal to 3 plus 6, 9. 4 plus 8, 12i. So it is z1 plus z3. Next, find it modulus z1 plus z3 of modulus. So modulus 9 plus 12i, which is equal to square root of 9 square plus 12 square, which is equal to square root of 9 squared is 81 plus 12 squared is 144, which is equal to square root of 1 plus 4, 5. Here 8 plus 4, 12, and already 1. So 225. Okay. Modulus of z1 plus z3 value is 225. Simplify this. Yeah, it is a perfect square. Perfect square of 15. So modulus of z1 plus z3, which is equal to 15. Okay. See book page number 68. Book page number 68. Ask one question, Rama. The triangle inequality is satisfies all the condition of modulus z1 plus z3, which is equal to modulus z1 plus z3, which is equal to 15. Why? Any reason? Okay. Tell your answers. Any reasons, Rama? Reply for my member. Next, the homework. Exercise 2.4, 7th sum. Show that first part only, 2 plus I root 3 the whole power 10 minus 2 minus I root 3 the whole power 10 is purely imaginary. Is purely imaginary. Purely imaginary means condition z bar equal to minus z. So take it, given equation B z. So let z equal to 2 plus I root 3 the whole power 10 minus 2 minus I root 3 the whole power 10. Then take it z bar of this. So z bar means take it whole bar. And then write it separate bar. 2 plus I root 3 the whole power 10 minus 2 minus I root 3 the whole power 10 exists. Okay, and then write it separate bar. Take it bar means here 2 minus I root 3 exists, here 2 plus I root 3 exists, which is in the form of z, but here 2 plus I root 3 is positive, here exists 2 plus I root 3, here negative exists. So take it minus commonly outside, we get minus z. So z bar equal to minus z. So we said it is purely imaginary. Okay. Now see exercise 2.5. Exercise 2.5 first sum. Find the modulus of the following complex number. Find the modulus of the following complex numbers. Questions are see in your book, Dhamma. Don't use it a phone only. Okay. First question. 2i by 3 plus 4i. 2i by 3 plus 4i. First question. What is it? 2i by 3 plus 4i. Find it a modulus of this. So modulus of, which is equal to, write it separate modulus. 2i divided by modulus of 3 plus 4i. Now, modulus 2i is nothing but square root of 0 square plus 2 square. Am I right? So square root of 2 square root get cancelled, we get 2. And then here also square root of 3 square plus 4 square. Simplify this, we get some modulus value. See the second sum. 2 minus I divided by 1 plus I into plus 1 minus 2i divided by 1 minus I. First find it conjugate of these terms. 2 minus I divided by 1 plus I into 1 minus I by 1 minus I. We got some result. Am I right? Yeah. And then find it here. 1 minus 2i divided by 1 minus I. Taking conjugate 1 plus I by 1 plus I. Here we got some result. Here also we got some result. Add these two terms, which is in the form of real and imaginary. Real and imaginary. Okay. Next see. Third sum. 1 minus I the whole power 10. 1 minus I the whole power 10. Before that we find some result of this, taking modulus of here. Taking modulus of these terms. We got result 2 into root 2. Okay. Simplify. Any doubt in this question means ask to me more. Third sum. 1 minus I the whole power 10. 1 minus I the whole power 10. Taking a modulus of this. So modulus we can write it as modulus 1 minus I the whole power 10. Modulus of 1 minus I, as usual, square root of 1 square minus 1 square. So we got square root of 2 the whole power 10. Square and root get cancelled. Finally we got, what is the result? Square root of 2 power 10. Square root of 2 power 10 exists. Square root of 2 is nothing but 2 power 1 by 2. The whole power 10. Cancel it. Finally we got some result. Okay. And then fourth sum. Fourth sum is 2i into 3 minus 4i into 4 minus 3i. Okay. Write it in a separate modulus. Modulus 2i, modulus 3 minus 4i, modulus 4 minus 3i. Okay. Here square root of 2 squared. Here square root of 3 square minus here plus minus 4 the whole square. And then here square root of 4 square plus minus 3 the whole square. Finally we got some result. Okay. Homework is over. Thank you, students.